Friends, IFES, the International Federation of Engineering Education Societies, connecting the global engineering education societies to develop its members' collective strength to improve engineering education worldwide since its inception on 9th October 2006 during Global Colloquium on Engineering Education in Brazil. Today, after 10 plus years of existence, IFES with 77 representatives from 47 organizations, 9 internationally reputed industry partners with 4 vibrant student organizations spanning across 27 countries to fulfill its vision towards engineering excellence to meet the global challenge. Through its partnerships and collaborations, IFES continues to serve its mission of providing a global network of engineering education stakeholders to meet the global challenges. IFES has also played an instrumental role in founding of the Global Engineering Council and the International Institute for Developing Engineering Academics, and also the SPEED, the Students Promotion for Engineering Education Development. I strongly feel that IFES, together with GEDC and SPEED and our member societies and our industry partners, can play an active role in this transformation process. We are currently witnessing a significant transformation in education and especially in engineering education. There are two essential and challenging elements of this transformation process that must be tackled in education, which are the first one, the impact of globalization on all areas of human life, and the exponential acceleration of the developments in technology as well as of the global markets and the necessity for flexibility and agility. As global players, IFES, GDC, and SPEED have a special responsibility for the exchange of the needs, experiences, best practices, etc. in the engineering education between institutions as well as the industry. The requirements for engineering education coming from emerging technologies such as online engineering, Industry 4.0, additive technologies, robotics, machine intelligence, IoT, and many others have to be discussed more in depth. The educational concepts from the past have to be checked and adopted in a disruptive manner. I strongly believe that IFES and the GEDC, their members and partners, are the ideal community which would put engineering education into a more cross-linked global context and would also create considerable synergies. The main approach for engineering in the 21st century is collaboration, and this must happen on many levels within a university or college, for example, by creating interdisciplinary and multidisciplinary solutions for complex problems between universities as well as with respect to a global scale. There are numerous benefits that derive from university industry relationship, including benefits to society, universities, and companies. Let us work together to make the difference in engineering education a reality, a change that already started, a change which is a global one, which needs the close cooperation between universities and industries from different countries as well as different regions. In this aspect only, our coming the year 2018, the month of November, there will be a Web World Engineering Education as well as GEDC 2018 conference on peace engineering with respect to the prosperity, sustainability, social equity, diversity, culture of quality, innovation, and entrepreneurship. I request all the participants who are here kindly participate and encourage the so-called industry and academia in a very big way. As well as in the year 2019, in India, we are going to have the yet another conference with respect to IFES, which is going to be the transforming engineering education through disruptive technologies, Industry 4.0 era. So the IFES has come up with a lot of initiation to promote not only the curriculum development, not only the leadership initiation, not only the quality assurance, they are also into the bridging the gap between industry and academia. In fact, I must be very thankful for the opportunity given to me by the IFES Secretariat, and I also thank Christina as well as Anne Sawyer for this opportunity. Thank you, one and all.
Thank you so much, Professor Manivanan. As our Vice President for Industry and Academia for IFES, you certainly helped us remember the important ways that we are connecting not only industry and academia, but our Global Engineering Deans Council, our students from SPEED, and our participants from around the world. And we are looking forward to our WEEF in 2018 focused on peace engineering. Today, participants, we are so excited to welcome our two presenters, as well as to have you be active participants in this webinar series. There are two ways that we will welcome your feedback and contributions as we go through this webinar. One is that we'll be asking polling questions where we'll be able to get your feedback in real time. And the other is through the chat function, where you'll be able to go through question and answers with our panelists. So today, let's first do a poll to see where each of you are located. So we're curious, where are you in the world? And so you'll see on your screen, what region are you from? Please go ahead and respond now. We'll give you just a few moments. Okay, hopefully you've had enough time to let us know the region you're from. Let's go ahead and look at the results. Wow, we've got a pretty good representation from around the world. It's great to see so many of you that have been able to join us today. We're going to go ahead, as I mentioned, to use these types of polling questions as well as our chat function for you to be able to not only ask questions of the panelists, but also if you're to have any technical issues, that's a way to reach out to us. This webinar series is going to be archived and housed not only on the IFES website, but also on our YouTube channel. So you'll be able to revisit these great presentations at a later date. And we'll also have some very special resources that we'll be sending to you with a link in a post survey as soon as our webinar is done. But without further ado, I'd like to first welcome PJ Borman, the Director of Education Marketing with MathWorks. PJ is going to be discussing with us today how accelerating discovery and learning through industry-academia partnerships connects with her work at MathWorks. Thanks so much for joining us today, PJ.
Thank you as well. Thank you so much, Christina. Can everybody now see my desktop? Clear?
Yes.
Great.
Yes, yes.
So it's my pleasure to be here. Thank you so much for inviting me to join you. I am the Director of Education Marketing at MathWorks, and our mission is to accelerate the pace of discovery and learning in engineering and science. So we see the topic today of industry education partnerships as being key to our mission. So,
PJ, apologies, they still can see my screen.
Sorry. Share desktop. Let's see. Are we good now?
Yes.
Perfect. Great. So just a little bit about MathWorks. I'm located in our Natick office of MathWorks, which is near Boston. It's where this logo is on the map. We're actually having a blizzard today, so for those in warmer climates, I'm jealous. But we have over 4,000 employees with MathWorks worldwide. We have offices in 15 countries, and our tools are in use in over 175 countries worldwide. So you may know us primarily from our major products, MATLAB and Simulink, but we also have over 90 toolboxes that are used to solve problems, visualize ideas, and to create new products. So I imagine many folks on this phone already have some sort of partnership with us in education. We work with over 7,000 schools worldwide, ranging from higher ed to primary and secondary. And over 6.5 million students and faculty have access to our tools. We also partner with publishers with over 1,900 books in 27 languages written about our tools. And we have a number of important online learning initiatives. And to date, over 1 million students have used our tools in MOOCs, such as edX or Coursera. But what you may not know about MathWorks is the depth and breadth of our usage in industry. So we have a variety of partners ranging from the leading automotive manufacturers, as well as aerospace, defense, medical devices and semiconductors. So as we think about where our tools are used, they're used for the next generation of fuel-efficient cars and autonomous vehicles. They were also used to help put the orbiter on Mars. And as we think about Industry 4.0, they're used with key technologies related to Industry 4.0, whether it's improving industrial systems or robotics. So our tools are used to tackle grand challenges, and we want to prepare students to tackle those future challenges as well. So when we think about Industry 4.0, there are smart devices all around us. There are smart assets, they're interconnected, they're leveraging cloud infrastructures and big data. And with those systems, we see the opportunity to optimize them and to collaborate and innovate together. And that's really key as we look at the ecosystem for collaboration and innovation. So as we think of key topics such as deep learning, Internet of Things, robotics, autonomous vehicles, there's so much opportunity to take some of the great ideas and research and discovery in our research universities and to be able to, from those, create new tools and technologies and develop new products. And this could be from either incubators or startups, or really evolution of existing businesses to create new business opportunities and new jobs and careers. And here's where we see an opportunity for workforce training and development and curriculum redesign, looking at how we better prepare students to prepare them for these future jobs. And so at MathWorks, we work with all of these ecosystems, whether it's campus work with universities, with our offerings, as well as industry work, and collaboration as well on curriculum and training. So when we thought about the best practices that we wanted to talk about today for this talk, I'm going to focus on 4 key areas. One, we think it's critical, absolutely critical, that industry software be leveraged as well in universities for research, teaching, and learning to better innovate and discover with the real tools that students will be using when they graduate. The second is identifying training and online learning opportunities to train students in those key new areas that are emerging, such as deep learning. And we see online learning as a wonderful way to provide lifelong learning for students and access across the world. The third is curriculum. We see an opportunity to develop new curriculum together and also to be able to share best practices on curriculum worldwide. And finally, student competitions. We see student competitions as a fantastic way not just to give students the technical skills they need, but the soft skills, the leadership skills, the teamwork, the collaboration that is so important to use when they graduate and have jobs as well. So we think student competitions are a fantastic ecosystem to give that balanced training to students. I would like to pause here and take a poll and ask the question of this group of, are you ready for Industry 4.0 and what do you most need at your university? So let's take a minute and do this poll. Okay. So let's see the results. Okay, training. That's good. So training's the priority and curriculum followed by student competitions and software itself. That's great. So let's start with the first topic and start with industry software. So why is this so critical? Let's look at an example. This is an example from a company in Australia called Building IQ. This is an adaptive building energy management system where they take into account a variety of factors for heating and cooling. First, the comfort level of tenants and also energy prices, as well as weather conditions. And from there, they use an optimization program to determine what is the best temperature for the tenants at the right price points as well. So here's an example of a traditional heating and cooling system where when you go into an office, for example, the temperature may be changed in the morning and then it's more time-based. It may change later on when you leave work. If you look at building IQ, their system above is more adaptive, it's more dynamic. And as a result of taking those factors into account, they can have up to a 25% cost reduction. That's a real savings on energy costs. Here's a second example from Respiri. Respiri is an asthma and wheeze detection system. And with Respiri, you put a device under your chin and it can capture the sound waves and the ambient, and filter out ambient noise. And it assesses those sound files using machine learning against pre-trained 40,000 audio signals and voice prints. It can then feed that information to a mobile device or a cell phone to characterize the wheeze. And with this information, you can determine, is it urgent to go to the doctors or the hospital? Or perhaps you don't need to, and you can save that time and money. And devices like, and resources and technologies like this can ultimately save lives. So when we look at both of these examples and think about Industry 4.0, these are examples of Internet of Things. In both cases, there are smart connected devices using communication and sensor analytics where you can use a tool such as Simulink. And they also leverage exploratory analysis and algorithm development where you can use a tool such as MATLAB. And finally, they have online analytics and a storage device for visualization and reporting, such as ThinkSpeak. And so you can use the same tools that are used in industry for these innovations in our universities to prepare students for Industry 4.0. The topic of deep learning is another key topic for Industry 4.0. And if you look, this is data from KPMG, and tens of billions of dollars are being invested in deep learning. And as you can see on the right in the graph, it shows that the talent is concentrated in some key high-tech companies as well as universities. There's a real need for talent here, and it's scarce. So as we think about tools for better preparing students for deep learning, here's an example of how you can, with just 5 lines of code, do image recognition and identify the difference between whether it's a coffee mug or a lemon and with finer granularity, a ping pong ball. And this technology is becoming stronger and stronger and evolving each day in key areas such as deep learning. So I know many of you were interested in training from the poll. We see an opportunity to identify those key areas where we see job opportunities and to provide training in those key areas. Here's an example of 2 free training examples. One for online training. This is 2 hours of deep learning training online. And as well, there's a downloadable ebook that's also free both for faculty and students as one example of a way that we can greater expose both faculty and students to some of the key areas where we're seeing job opportunities as well. So I want to turn next to the third area, which were curriculum and teaching innovations. Here are 2 examples of teaching innovations, and we believe that we should share examples such as these as broadly as possible to hopefully partner with you to accelerate improvements in engineering education. So this is an example of a MOOC that was developed from Vanderbilt. And over 100,000 students have now used this MOOC for programming. And it's from Coursera, so it's available worldwide and open access for learning programming. The second example is from Boston University from Professor Stormy Attaway. And Stormy Attaway has flipped her classroom where she'll have lectures or videos that students review prior to class, and then they'll come to class and do more active learning. And she's seen increase both in attendance and student engagement as a result of doing this. And she also includes auto-grading. She uses auto-grading and assessments to help be sure that she understands where students have challenges so that she can address them more directly. Here's another example from University of Eindhoven of how they've seen benefits of auto-grading, both to save time and have greater student engagement. And we see this as really important because by saving some time, it can hopefully enable more active learning, more engagement with students through project-based learning. And here are some examples that we see worldwide of different ways to engage students with active learning, both in the classroom and outside of the classroom. And some of these are, this is from TU Eindhoven, TU Munich. And as I look at these, I wish I had had some of these engagement activities when I was a student as well. Here's some new innovations that we're also seeing. This is an example from Arduino for an engineering kit that they're developing this spring to bring self-balancing motorcycles, mini rovers, and a drawing robot into undergraduate curriculum with online materials as well. And here's an example from MIT where they're now bringing Parrot mini drones into both their undergraduate and their graduate level control courses. And I'll make available some of these links as examples for more information about using the Parrot mini drone. And in this particular case at MIT, they've actually had increased enrollment in this course and student engagement as a result of bringing the Parrots into their course. And finally, competitions. I mentioned competitions as a unique way to tackle Industry 4.0 challenges and tie some of these ideas together to make an impact. Here's a quote from GM, one of our partners, about the impact of student competitions. And we're grateful to have some wonderful partners in industry worldwide that works with us on these student competitions. And GM has one called EcoCar, as well as SAU AutoDrive, which is for autonomous vehicles. And GM does provide cars to these teams when they're competing. Here's another example for the topic of robotics for Industry 4.0. RoboCup has leagues ranging from primary school all the way through advanced humanoid robotics at the PhD level. And when teams win with our tools, we try to celebrate that so that teams worldwide can learn from them. So here's an example from Tokyo Tech where we have a winning team as well. So you may wonder, why is MathWorks involved in these competitions? We believe that this is a great way to train students and prepare them for their future careers. And also we learn a great deal, both from the students in universities we partner with, as well as our partners as well in industry. And what do we provide student competition teams? A variety of things, ranging from when we sponsor a team, we provide free software, as well as training, deep learning training, MATLAB training, computer vision as some examples, as well as community. We try to create community with Facebook groups and social media and examples that they can share. So Christina asked us to also be sure to, candidly say, what are some of the challenges that we face when we have partnerships, and what are some of the lessons we've learned? And first, we want to be sure we're aligned on our expectations. We want to have clear expectations of how you define success so that we can help you be successful. And we want to have our partners feel like this was mutually beneficial, any partnership that we do have. Second, time. A key question we have is, how can we start the process early? We have budget cycles, we have planning cycles, so as early as you can notify us of your plans, the better chance we have to be successful together. Sustainability. We want to make a sustainable impact together. We don't just think long-term, we try to think, short-term, we try to think long-term as well, and be sure that we can make an impact both short-term and long-term with you. And finally, scale. We want to share the results of our work together as broadly as possible with the hope of improving engineering education together. So in summary, as we think about these 4 primary best practices, leveraging true industry software for research, teaching, and learning, targeting training and online learning in key areas where we see opportunities to tackle Industry 4.0, sharing curriculum broadly and developing new innovative curriculum together, and student competitions. At the end of the day, we want to prepare the next generation of scientists to tackle the same technical issues as professional engineers. And if I leave you with one thought today is we hope to partner with you and keep this dialogue going long after this call today. So, and I will leave it with my contact information, and I could take a few questions.
Great, thanks so much, PJ, for not only providing us with some incredible examples of best practices for university and industry partnerships, but again, also going into some of the challenges and lessons learned. It does look like we have a couple of questions for you. One is about the possibility or the options for faculty training with MathWorks. Can you speak to that, please?
So we have a variety of different training options. So the examples that I've shown you are some of our free offerings. We also have more in-depth ones, and I think we need to understand what is needed at your particular campus for your needs. So that's one where we have a variety of different types of training, and so that would be a good one to have as a follow-up directly to me so that I could understand what would be most appropriate for your university.
Excellent. And again, to our participants, we have these webinars archived on our website as well as on the YouTube channel. We'll also be sending out a post survey, and in each of those areas, you will be able to see our panelists' contact information. Another question that we have for you, PJ, is how do we initiate an impactful discussion on design education, which would result in new thinking and a concerned action to revise the curricula and the methodology for design education in our engineering institutions?
So this would be a great opportunity where this particular person who posed this question could come directly to me, and I could get them in touch with their local regional resource. So we have context depending on the region of the world that could be helpful in talking in more depth about what could be a meaningful proposal to work on together. But I think in light of, I could be the first place to start, and I could be sure to include the right representative from MathWorks in that dialogue.
Excellent. Well, I know that there are more questions coming in, and so hopefully at the end of our webinar session, we'll be able to tap into those questions. But I'd again like to thank you so much for your great session, for providing us with very interesting examples, as well as a wide range of resources for MathWorks. I'd like to now welcome Xavier Fougère, who is our Global Academia Programs Senior Director from Dassault Systems. Today, Xavier is going to be speaking on developing the workforce of the future, a joint academia and industry challenge. Thanks so much for joining us today, Xavier.
Good morning, good afternoon, or if you are among the 7% who are listening from Oceania, good night. There is no time in the day to talk about that subject we are talking about. We have to spend all our energy in making this connection between academia and industry stronger as we face the challenges of the workforce of the future. When you look at the different reasons to establish and nurture relationships between university and industry, they are multiple. But among them, you will always find a large category of desired interactions that relate to the learning experience and the quality of learning of the students. This is what I would like to focus on. And since my time is limited, and by the way, you will hear in 20 minutes, 19 minutes from now, you will hear a duck quacking. That will be my iPhone telling me that my time is over. In the time left, I would like to address these subjects. Internships, because I think it's one of the most efficient instruments to improve the quality of education and the quality of the learning experience of students. curriculum enhancement and educational research, not research in general, but educational research that goes together with curriculum enhancement. On the other subject, we can have a chat at any other time. I will leave my contact at the end of this webinar. Now, if we focus on these subjects, how to enhance the curriculum in a context where engineering practices are moving extremely fast, and they move in industry. That's where the practices are moving. The principles of engineering are not so different than the ones of yesterday, but the practices of the profession are changing every day, and that is happening in another place than the university. A way to deal with this situation is educational research that involves both education and businesses. This is what I would like to focus on. Now, we are in a context of deep changes among the what in terms of what engineers do or will be doing, and therefore in terms of what they need to learn when they are students. This map you see currently is a summary, an extract of a few, it's the most representative ones, of the initiatives that are driven at a country level, usually driven by government, to modernize industry, to take benefit of all the new technologies that we have now in our hands, to create another kind of industry. We call that industry renaissance, because we don't want to choose among those different names that you see. One that has been very influential is Industry 4.0, and in many countries the name has been adopted to describe their national initiative. But in other countries there are other names. That's why I think it's broader, it's more encompassing when we speak about industry renaissance or the fourth industrial revolution. We heard that, but the essential dimension of all that is that this movement is happening very strongly in industry, and as a company that provides the instruments, the digital instruments to make this happen, the System is involved. The company I belong to is involved in most of these national manufacturing initiatives. Out of that, we learn. We learn what will be the coming practices that will be required to operate this new industry. They will be required from technicians, they will be required from engineers, they will be required from operators, from management, but I will focus now on what will be required from engineers. When you look at these initiatives, look inside them, how they are organized, you will find commonalities, a lot of commonalities. On the left side of this chart, you see the kind of methodological ingredients that are forecast to be growing as part of those initiatives. And on the right side, you see the political instruments that governments have or mobilize to make this happen. And of course, among those instruments, academia, vocational and professional education is a very essential one. Remove this one and nothing happens. So on my side, I have a very specific view on all these changes because we are involved in the digital dimension of all that. And what we see here is that a challenge that we all share, university and academia, the challenge is that we don't know the jobs. We don't know the future jobs. We have a clue, we have some feeling about the future competencies, the skills that will be necessary, but not necessarily the new types of jobs. And this is creating a difficulty in terms of constructing the most appropriate curricula. Add to that there is a very strange paradox in curricular innovation. The graph you see here relates to an industry best practice that has been put in place over the last 20 years. This is called digital mockup, and I use a picture on the right side of this slide to show an example of how a digital mockup looks like. Basically, it's about having the most comprehensive representation of any product, not just cars, whatever their complexity, and use that to organize the engineering work in the whole development process, in the whole development team, beyond engineering sometimes. And this practice is called digital mockup, or DMU, and it was invented in academia. And here we start our spiral on the left as a new way to organize development cycles. That was initially described in a paper from a professor in the University of Michigan. And then the vendors of tools, like the company I work for, like Dassault Systèmes, have been developing tools to support this type of process. Out of these tools, users like car makers, airplane makers were first, in fact. Users employers of your graduates did start to develop methodologies. How in our context can we apply these tools to practice this DMU method? So they did internal training of their teams, and gradually the practice reached out the whole industry, other industries than the one it was emerging from, and it became a standard engineering practice in industry. And then only after 10 years, this cycle was 10 years, we could start to see in curricula that digital mockup became at last a subject of teaching and learning. This cycle is too long, and it has been my work for the 10 last years to try accelerate these things. The transfer of new ways of doing things as they appear in industry into the curriculum. And to do that, of course, we need to use digital technologies. We cannot escape digital technologies, and in our future, these digital technologies will even become more critical, because the machines we are working with are just getting more and more intelligent. So they will transform the nature of jobs in many, many places, especially in digital jobs. The little illustration you see in the video is about using virtual reality to help program a new type of robot work cell, which is called a collaborative robotic work cell, in which humans and machines share the work. That's not science fiction, it has started. The question is, how do we prepare engineers to design working processes that are hybrid between machines and humans? That's the kind of question I try to answer in my learning lab here in Paris. We have established such a lab that works in the form of educational research together with universities on those new practices that come from industry to make them applicable in different types of educational contexts in the form of fully documented educational activities. We do that through grant research, and we work together with principal investigators who are professors. Here is a subset of what has come out of this process. It's a sampling, and when you see the topics, they are all related to the future of the industry. They are all related to the new challenges that we have in engineering education to transfer to students the most recent practices that are emerging in industry. And as you see, the work we have done is to use digital techniques, the most advanced ones, collaborative on the cloud, etc., to document learning activities that are relevant to those topics. And we did so in collaboration with universities of which you see the names. This is not a complete list of what is necessary to do. It is not the complete list of what we have done and keep doing. The work is immense and challenging, but extremely exciting. Take one other example. Central to the industry of the future is the industrial Internet of Things. And central to the industrial Internet of Things is a notion called the digital twin. There is a whole story about the digital twin, how it was invented by NASA and how it became a generalized digital practice. But the question is, how can a company that provides tools to industry, like Dassault System, help educators in having their students fluent in this new concept? We have been using a robot, an open source robot model, because most of the teachers were asking us not to use a robot that they could not modify for their own purpose. And we have developed multiple activities to illustrate the key concepts of the digital twin based on this robot. The way we have done that is by inviting students to intern in our lab for several months, never less than 3 months. Here you see one of those students, a Colombian student who came here in Paris for 6 months to develop educational activities based on these robots and to make it a universal tool for discovering the practice of the digital twin. This is now all documented, all online for those institutions who are using the software we talk about. And this gives me the occasion to transition to my second subject, internship. It is very central. So, conclusion of the first part, educational practices of the future can be developed very quickly if they are derived from emerging industry practices. And the link to make that happen quickly is provided by places like the Learning Lab that I was presenting to you. By the way, if you want to visit it, it's in Paris, and we organize virtual visits for remote people. The power of internship. The picture you see is just a picture that was taken one day of the team of students working in the Learning Lab in Paris. But it's just a way to illustrate what I want to share in terms of what they learn. They learn things you will not be able to, in educational institutions, to have them discover. That's social skills that govern a company are not the same as those that you see in an educational institution. The professional behaviors, how to be on time. That's when I am to to rate a student interning in the team in Paris. I receive a rating grid from their schools, and I have to answer questions such as this one. Are they on time? Do they keep their word? Do they not overpromise? Do they guide their work by themselves? How often do you need to talk to them to have them progress? Do they ask questions? These are all attitudes. And of course, aptitudes. Aptitudes about the emerging methods that I was mentioning before. And aptitudes about their knowledge of how companies operate, which is not something you can learn in books. You have to learn that by experience. So you have to learn by experience the attitudes. It's not enough to read a book that tells you to be on time. You have to be in that situation where you need to be on time. And these internship, they create also very valuable opportunities for the students to be employed. All statistics worldwide show that if you are employed as an intern or as an apprentice, your chances to be hired definitely, or as a permanent employee of the company increase drastically. And other types of opportunities, which I will never insist enough on, it is a way for educators to learn about what are those new practices emerging in industry. It is a way for educators to get their own continuing education, because they are supposed to mentor at a distance, usually, to mentor the activity of an intern. They have then an opportunity to go very deeply into the nature of what they are doing and what they are learning about those new emerging methods. And there is no better way to learn this. So, and the problem about this marvelous format that is internship or apprenticeship is that it is not uniformly enforced. There are countries where it is compulsory. What you see on the right, well, I have it in French because what you see here is a rule from the French accreditation agency, but I have translated that in English for you. It just says that you cannot graduate as an engineer if during your education you haven't received at least 28 weeks of internship. And at the other end of that spectrum, a few weeks ago, the Indian authorities have announced that internship would be compulsory. But it was not so far. And this has led to this type of numbers where only 1% of graduates in India has had an opportunity to get a serious internship during their studies. I wish this reform will happen. I know it will not be easy, because when you try to put that in place, you need a systemic transformation. Companies have to participate actively, as they have been in countries like France, but other countries that I know in Europe have 100% mandatory coverage of internship within the engineering curriculum. So between 1% and 100%, we see all sorts of intermediate levels, but I think we have a big challenge in front of us worldwide, and that's typically a thing where IFES can be an efficient instrument to help and accelerate, to make the employment experience part of the learning experience. With that, here is a little poll that you will receive in your school. In your school, not in your country. Are internship mandatory for all students to graduate? Yes or no? And same question afterwards about your country. Is it in your country? Is it mandatory for students to have internship? So you had time to click on 2 buttons, and we may see the results now. Okay, you see, it's not, it's a 50-50 in the audience. And we see better results in schools you represent than in countries. That's because your schools are probably more pioneering within your countries in terms of modernizing the curriculum. Thank you. If you want to read more about the subject of curriculum improvements through academia and industry relationship, there has been a research project, a European-funded research project called Eugene. And in that project, there is one work package that was delivered about the subjects you see in the list here. The document will be put online as a post-webinar reading. With that, thank you.
Thank you so much, Xavier, for the fantastic presentation, including providing some really important examples of the interactivities between industry and university, as well as ways we can continue to think about adapting our curriculum to really make sure that our students are ready for employability in the future of our industries. We do have a few questions that I would like to pose to both you and PJ. One of the questions that one of our participants has asked is there a mechanism for which we can use to encourage industry to key into industry academic collaborations? This is a key challenge that they're having in Nigeria.
Yes, it is very country dependent, because in some countries you will have established relationship models. When you are in an African country, the first challenge you will have is to find an industry partner who may tell you something, and frankly, it is difficult. I know it is difficult. Nigeria has an industry. I would say start with contacting the HR people, but never stop with that, because HR people in companies are interested in staffing the positions they have currently open. When it is about anticipating what kind of jobs a specific company will have in 2, 3, 4 years, you have to talk with the actual engineering divisions, the people who are working daily with engineers. So contact the HR divisions of your main industry, and then go further into the engineering departments. The issue that this is not covering, the dimension that this is not covering, is small and medium businesses. Large companies are well organized, they have HR departments, well structured. Smaller companies do not have that. So then there are other mechanisms to work with smaller companies, but that requires a very local type of approach, because here the structures of the industry are very heterogeneous based on which country you look at.
Thank you. We have a second question for both you and PJ. Is there an interest in a global curated digital platform to consolidate and communicate industry-supported in-class project opportunities for higher ed institutions? Most engineering schools moving fast this way, but each trying in parallel to set up a pipeline of industry-based projects which isn't very efficient?
This is a great question. I think there may be a need, but a uniform platform of this nature will never happen, because there will always be competition, because some schools will prefer one platform to the other. But at the end, it is extremely interesting to explore the possibility of having a very generally accessible platform on which engineering schools from the whole planet could decide to establish collaborative learning experiences across dispersed institutions. Great question. The people who asked that should send me a mail. I would like to entertain a conversation on that.
Yeah, I'd like to chime in on that one too. I think that's a very interesting idea, but to Xavier's point, I think there are so many different platforms at each individual institution. Some are really dominating certain regions of the world. So when we think about learning platforms and where students are, what we try to figure out is what solutions, and in this case it would be looking at these examples or projects could work with a variety of different platforms. So I think your idea is a very interesting one, and our challenge with how to make it platform agnostic so that people using discrete learning management systems or different platforms for learning could then leverage it. But I think that's an interesting idea. Thank you.
Thank you. And we have one time for one more question. One is, are there project modules that consist of complete projects that students can do from scratch to end?
Yes. Yes, they are. Content-wise and methodology-wise, because there are two things in that question that are meeting. One is the nature of a project. What is it about? Is it industry realistic? And the second aspect is about the methodology, the project-based learning methodology. And there are different such methodologies. You have PBL, you have CDIO, you have different methodologies that encourage project-based. These two things, when they are meeting into one single learning experience, produce extraordinary results. And if you want to see some of that documented, I can provide you some details where these documents can be seen.
Agreed. I think it would be helpful to understand from, there are definitely a variety of different projects that we could share with you. I think it would be interesting to know which projects do you need most so that we can direct you to the right resources. But that would be helpful for me to know as a follow-up question to whoever posed it.
Well, with that, I'd like to go ahead and thank each of our participants for joining us today, as well as for providing us with your feedback, comments, and questions. I'd especially like to thank our presenters today, Professor Manivanan, as our Vice President of Industry and Academia Relations, for really helping contextualize the work that we're doing at IFES with bridging the gap between universities and industry. I'd like to say a special thanks to PJ Boardman for really helping us understand the important and relevant work that is going on with MathWorks and the great resources that you provide our universities as well. And a special thanks also to Xavier Fouget for the hard work that's happening at Dassault Systems, again, to really prepare our students for moving into what we're considering the Industry 4.0. To each of the participants, I'd like to remind you that our webinar is going to be hosted on our YouTube channel and on our IFES website. You will be receiving a post survey where we're able to ask you some of these questions and make sure that we're providing you with the resources that you're interested in getting. There will be a special link at the end of that post survey that will also guide you towards more resources, both from MathWorks and from Dassault. Again, we look forward to you joining us in our upcoming webinars. And if you have any questions or comments, you can reach us at the Office of the Secretariat. And great thanks again to the Office of the Secretariat of IFES for your work in promoting and producing these webinars. Thank you, and we look forward to talking with you again.